The nice thing about the periodic table is that there are certain trends that apply when you write it out. We can use these patterns to predict certain properties of each of these elements. For example, let's talk about the atomic radius. It's the measure of the size of an atom. Sometimes atoms are large, sometimes atoms are small. As you see here, atomic radius increases as you go from the top right to the bottom left, which means that elements that are on the bottom of the periodic table are larger than those on the top, and those elements that are at the left of the periodic table are larger than those at the right. Let's go through an example here. If I were to compare these four elements and I wanted to choose the largest of all of them, you can see that the bottom one would be a larger atomic radius than the other three. This is because it has more principal energy levels, and the last electron is moving at a much higher energy than any of the other three elements. Here's another example. If I compared these four elements, you could see that the one on the left would be a larger atomic radius than the ones on the right. The next periodic trend you should know is ionization energy. This is the amount of energy necessary to remove the easiest electron from an atom. This has to do with atomic size. The larger the atom, the farther away the outermost electron is from the nucleus, the easier it is to steal. So it would take less energy. So let's look at the trends of ionization energy. Notice that ionization energy decreases as the atomic radius increases. So if I were to compare these three elements, the one that would have the lowest ionization energy would be the bottom one. Notice it would also be the largest element. If I were to compare these two elements, the one that would have the lowest ionization energy would be the one on the left. Once again, the larger of the two atoms. The next periodic trend you need to know is electronegativity, also very important when we get into chemical bonding. This is the tendency of an atom to gain an electron. The more an atom wants to gain an electron, the higher its electronegativity. Here's the trend for electronegativity and how it increases. Notice it goes from bottom left to the top right. If I were to compare these three elements and wanted to know which one has the highest electronegativity, it would be the top one. If I were to compare these three elements and know which one has the greater electronegativity, it would be the right one. In order to make sure that you understand what electronegativity is, I want you to understand that electronegativity is only high when the element wants to gain an electron. If I were to compare these three elements, a lot of people would think that the farthest right would be the most electronegative. But don't forget that that element on the far right is a noble gas. It's already stable according to the octet rule. It does not want to gain an electron. So of these three, the most electronegative element would be the one in the middle, because it really wants to gain one electron to be like a noble gas. In summary, as you go down and to the left on the periodic table, atomic radius will increase, which means the ionization energy, or the energy to remove an electron, will decrease. And that means the metallic character increases, because remember that metals like to lose electrons. So if it's very easy to remove an electron, it becomes more metallic in character. The opposite is true as you move to the top right. Atomic radius will decrease, electronegativity increases, meaning it wants to gain electrons, which means the non-metallic character increases. Remember that nonmetals like to gain electrons. So if we are talking about metals, metals become more reactive because they become easier to remove electrons as they go to the bottom left. If we're talking about nonmetals, they become more reactive as they go to the top right because they want to gain an electron.